portfolio returns, summary measures, session prerequisites. Browse to our earlier material on distribution of returns. In preparation, please have the spreadsheet and RStudio open on your computer and follow along. Maximum benefit guaranteed. Learning objectives. Build a general model for a portfolio with N stocks. Derive summary measures of the portfolio returns based on the component stock returns.
Let's build a general model for a portfolio with N stocks. We'll use random variables R1, R2 through Rn for monthly returns. Notice these are variables, they are not constants.
I know. The return on each stock changes month on month.
$100 invested in stock I will grow to 100 times 1 plus Ri the next month.
Which means Ri could be negative?
Of course, our own portfolio has dipped once by over 20%, you know. Suppose A1 through An are the proportions in which we have invested in stock 1 through stock N. There are two things we observe.
Two observations. The weights A1, A2 through An must add up to 1. Each weight is greater than or equal to 0.
So if a weight is 0, then that stock does not feature in our portfolio?
You're absolutely right. Now the ROI for the portfolio is yet another random variable. We have it as the sum A1 times R1 plus so on plus An times Rn. Let's call this the return of the portfolio, which is Rp. With every random variable, we are interested in two key parameters.
Its mean and its variance?
Correct. Based on historical data, let mu1, mu2 through mun be average ROIs for the stocks that make up our portfolio. Then the mean ROI or expected ROI at a portfolio level is given by expected value of Rp is equal to A1 mu1 plus so on till An mun.
That's just the sum product of the means.
Correct. So what do you think of the variance of this variable Rp?
That's easy. It must be a sum product of the variances.
That one's a classic mistake, Lisa. If the returns are independent of each other, then we get the variance of Rp as A1 squared times the variance of R1 plus so on plus An squared the variance of Rn.
I forgot to square the weights.
Well, next time you won't. Realistically, we cannot expect two stock returns to be independent. Just check out these correlations here. By definition, the variance of Rp is the expected value of the squared deviations from the mean. Here's the equation. This expands to a sum of two terms. The first term simplifies to A1 squared times variance R1 plus so on plus An squared variance of Rn.
That's just like when the returns are independent.
Yes, each term inside the second summation becomes Ai times covariance of Rj. That's a correction for our stocks becoming correlated. Let's bring it all together on a slide.